Okay, this is the review for Chapter 5. So I'm going to go through the review plus a couple other bonus problems in the middle to make sure that if you're watching it, you get a couple things extra. So we're going to go through number 1. We have some different statistics here that we're looking at, and we're going to use this formula to convert the following. So what you have to imagine is we have this whole list of data. It has this mean, this standard deviation, this third quartile, all these different values. And we want to know what would the new mean be if we converted all the numbers by taking 3 times x and then subtracting 7. So let's remember, this is an exercise where shifting doesn't affect measures of spread. Everything else is affected by shifting and rescaling. So what are these numbers? We're just going to simply put them in. Three times 27, subtract 7. We would get 3 times 27, 61, subtract 7. The new mean would be 74. Okay? The new standard deviation, the standard deviation, 3 times 6.07 is 18.21. And then we're going to subtract values from this, but the standard deviation isn't affected by shift. So that one, in fact, let's put this in a different color just to make sure we get that idea. So remember, measures of spread aren't affected by the subtraction. Next, we're going to do the same thing with the 32. 3 times 32, that would be 96, subtract 7, 89. Q1, we don't have the original Q1, so we're going to have to use the first quartile, or the IQR. The IQR is 14. So the original first quartile must be 18. We just use that IQR to help us find the difference. Now you're going to substitute 18 in there. So 3 times 18, subtract 7. The new IQR, we're going to take 3 times that IQR. We're going to get 42, but then it's not affected by the shift. Range also isn't affected by the shift. And then the new maximum we would take. We don't have the maximum, so we got to find it. If the range is 25, the maximum, we would have to add 25 onto that. And then we subtract 7. So notice the ones in red, those are measures of spread. Those aren't affected by shifting. Number 2, we're simply going to look at these. You're going to assume you have a normal distribution. So I'm going to quickly draw a curve. So you do not need to draw a curve on these, but you should be used to drawing a curve. This is where you're going to take your calculator. Somehow my calculator got closed. I had it up, and then it closed, of course, right when I started the video. It's probably what I had on there that shut off. up and wait. Sorry about that. Okay. So we're going to go menu 652. We're going to go to normal CDF. On this one, we're just going to put in our lower boundary. Remember, our low boundaries are left hand and our right hand. We're trying to capture that part of the screen. So we're going from negative 2.33 up to 0.33. Sorry about the wait there. That was kind of annoying. Okay, so we get 62%. On this one, if I were to give that, all I'd be looking for is an answer, a simple 62%. This one is going to go from 1.25, it's going to go up to infinity. So we're going to do the same thing. Menu 652, doing a normal CDF. .25 to a really big number is 10.5% or 10.6%. That's all we're looking for on that one. Sorry, I'm writing with the mouse there. Okay, this next one, we're going to have a couple. We've got an absolute value problem. So the absolute value problem, this is 0, this is 1, this is negative 1. We're going to go from 0.34 on up, but the absolute value can also be negative 0.34 or larger. These values are also larger. So what we need to do is we need to find one of those, and then we need to double it. So a couple ways we can, of course, do that. I'm just going to do it the simplest way. Menu 652, I'm going to go from 0.34 on up, and then I'm going to take that value times 2. So the answer, that second one is not the right answer. It's the 0.73. Sorry, I hit enter twice. So this one is 73.3%. I'll do it one more way. I'm going to do it with a clean calculator screen. I'm going to go menu 652. I could go from negative 999 up to negative 0.34 and then double it. And that still gives me the 73.4%, I guess. Remember, we don't get caught up a lot in the rounding on the normal curve. This one, less than negative 1.33. So we're looking at that value. We would go menu 652. We're going from negative 999 to negative 1.33. And that one is 9.2% if we round it off. Just seeing if we understand the basics of the curve. Okay, this one is kind of a throwback question, spiral review, if you want to call it. In distribution, we have the following statistics: minimum, Q1, median, Q3, maximum. We do not have a mean, so we're going to use these. These are the old rules for outliers. So the rules for outliers, we're going to take, for the lower fence, we're going to take Q1, subtract 1.5 times the IQR. What's the IQR? Q1 is 12. The IQR would take 16, subtract 12. So the IQR is 4. So 1.5 times 4, that would be 6. 12, subtract that is 6. Are there any values below that? There are. There's at least one. There's at least one low outlier of 4, because 4, the minimum, is below that fence. There could be more. We don't know. There could be other numbers in there, but we know there's at least one. So now we're going to find the upper fence. The upper fence, Q3 plus 1.5 times the IQR. 16 plus 1.5 times 4 gives us 22. The maximum is 21, so there's no high-end outliers. Okay, so I'm going to do this in 2 installments of the video. That's the first half of the video.